Astrobiologists discover fossils in meteorite fragments, confirming extraterrestrial life. Researchers in the United Kingdom have found algae-like fossils in meteorite fragments that landed in Sri Lanka last year. This is the strongest evidence yet of cometary panspermia that life on Earth began when a meteorite containing simple organisms landed here, billions of years ago, and, perhaps more importantly, that there's life elsewhere in the universe. In December 2012, a fireball was seen over the skies of Polonnaruwa, Sri Lanka. Over the following few days, fragments of the fireball were collected and sent to Sri Lanka's Medical Research Institute, where initial microscopic analysis revealed siliceous microalgae known as diatoms. As you can imagine, with this being the first ever evidence that life might have arrived on Earth via a meteorite, the scientific community was skeptical of the results, and so some fragments were sent to Cardiff University in Wales for further analysis. The researchers at Cardiff are now reporting that they're sure that these fragments come from an extraterrestrial meteorite and that there are definitely fossilized biological structures within them. Panspermia, it seems, is a go. There are a few competing theories for how life began on Earth. Panspermia, where life arrived on the back of a comet or asteroid, is one. Abiogenesis, the theory that life spontaneously erupted from inorganic molecules in Earth's primordial soup, is another. Directed panspermia, where an alien race intentionally sent an asteroid or spacecraft loaded with living organisms to Earth, is another slightly more exotic theory. As for which theory is correct, we'll probably never know, but the Polonnaruwa meteorite definitely puts the odds in panspermia's favor. Cardiff University's tests took a two-pronged approach, first to confirm that there were actually algae fossils within, but more importantly to rule out terrestrial contamination. To this end, the researchers found very low levels of nitrogen, which is nearly always present in modern Earth organisms, and their oxygen isotope analysis shows that the samples are unequivocally meteorites. The meteorite's atomic makeup, coupled with the fossils being fused with the rock matrix, is a strong indicator that the organisms aren't terrestrial in origin. These findings aren't a slam dunk, though. According to our in-house biologist John Hewitt, there's a strong possibility that the fossils aren't actually biological in nature, they simply look biological. This is kind of like finding a Q from Scrabble floating in space. It may be worth 10 points, but finding a few S first would be a bit more convincing, Hewitt says. There's also the fact that the research was published in the Journal of Cosmology, a peer-reviewed journal that has come under critical scrutiny numerous times since it was established in 2009. The journal faced a lot of controversy when it published a paper by NASA engineer Richard Hoover claiming to have found fossils similar to cyanobacteria in meteorites. With that said, the work presented in the Cardiff University research paper does seem to be rather professional. X-ray diffraction and scanning electron microscopy are not really the kind of tools that you play around with. It would be rather hard to fake the imagery and results that were generated by Cardiff University. Not impossible, but unlikely. One thing's for certain, though, for this to actually become science, for Chandra Wickramasinghe's dream of panspermia to become a reality, this work will need to be replicated by many other groups around the world. It would be very, very exciting indeed if biological fossils have been found on an extraterrestrial meteorite. It would be proof that there's life on other planets and essentially a guarantee that the universe is full of life. But, as always, extraordinary claims require extraordinary evidence. You can also see research paper, arXiv :1303.1845- the Polonnaruwa meteorite, oxygen isotope, crystalline and biological composition.